This printer right here is the Rat Rig V-Minion. It's been out like, what, 4 or 5 months, and I've pretty much just finished assembling mine. The main printer has obviously all the main printing components, but the control board, power supply and Raspberry Pi for running Clipper is in this separate enclosure. That means all of the wires from this printer, all the little heater, end stop, probes and everything, all have to go back to that box. The standard design for the printer doesn't really have much in the way of managing that arrangement of cables, other than just like stuffing them into an umbilical. So if you want to ever do like maintenance or move the printer around or put it in an enclosure and be able to have like the box on the outside and then separate the two and all this kind of stuff, is just a bit of a pain to do. So I've created this PCB which allows you to wire everything from the main printer into a single PCB on the back, and then there's some connectors which connect all of that back to the electronics box. So all the instructions and everything you need to know about this modification are actually already written down in instructions that I have on GitHub. You don't have to buy anything, they're just available. You can read those and look through anything that you need. All the information that you probably will need should be in there. If it's not, let me know and I can add stuff to it. But I'm pretty sure you'll be pretty happy with the amount of information that's in there. So the way this comes is in a kit. You can either just buy the PCB on its own, you can buy like a partial kit, or you can buy like the full kit, which is the PCB, everything you solder to it, and then including like mechanical fixings, all the connectors that go into the plugs on the PCB. And so it's pretty much everything you would need to add this to a printer. While it is a kit, not everything you need is included. So you'll need some solder and a soldering iron. They're not in the kit. You'll need wires, not in the kit. And you'll need some slightly larger wires, also not in the kit. So you'll need wires that are suitable for like the motors and end stops and that kind of stuff. So fairly thin, low current wires, but you'll also need some higher power ones suitable for the hot end and the heated bed. The bed uses 180 watts at 24 volts, plus or minus a bit. So that's 7.5 amps of current. Be careful when wiring this. Make sure you get wires that are appropriate for that current. If you try to run a high current through a wire that cannot cope, it will get very hot and can cause a fire. So, you know, just be sensible. Make sure you're buying correctly specified components for the ratings that are needed. Obviously, you will also need the connectors and terminals to connect the wires to your control board. Obviously, this changes from person to person, so these are not included in the kit, and you would need them whether you're going to be wiring to this PCB or not. So again, they're not included, so make sure you get whatever you need for your specific control board. As part of the kit, there are some 3D printed parts, although they're not included, but I do provide the STLs. Again, those are on GitHub. There's an assembly jig, an enclosure, which is in 2 parts, and an end stop modification. In terms of materials, I would match the materials to what you've made your printer out of for the end stop and enclosure. The assembly jig can be pretty much any material like PLA is going to be absolutely fine. In terms of the printing settings, I would print the end stop, again, the same high perimeter count and decent infill, the same way you have the rest of the main components. But for the enclosure, you can probably get away with a couple, 2-3 perimeters, maybe 10 to 15% infill, and for the assembly jig, a couple of perimeters, 10 to 15% infill. For assembly, we start with the through-hole components, just poking the legs through the holes and bending them on the other side so they don't fall or just move anywhere. Next, we mount the microfit 3 connectors. They just push into place and click when they're locked in. Then we load up the assembly jig, place the PCB on top, and then we can solder everything into place. And we finish it off by trimming the legs off of the through-hole components, and if you want to, you can use some IPA to clean off the flux, but this is not really necessary if you don't want to do it. So that's your PCB now fully assembled. You now need some mechanical components to hold it to the printer and the wires. We'll start with the mechanical stuff. The parts that you fit to the printer look like so. You have the enclosure for the PCB itself, and a mount for the Y end stop. This is needed because we need some more vertical space at the back of the printer, so we move the mount for the Y end stop from the side of the printer onto the top. For the enclosure, there's 6 M3 hex nuts which need to be pressed in, 4 in the base to mount the PCB to this part, and then 2 in the back to secure the lid to the box. Before screwing the PCB into the enclosure, it's best to place the screws and M3 hammer nuts onto this jig, because the holes get blocked a little bit by the PCB, so you can't get the screws in when the PCB's in. It's not really a problem, you can still tighten them and adjust them, you just can't insert the screw into the hole. So screws in, nuts on the back, and then place the PCB into the tray, and you can screw it down too. Once you've got your mechanical parts sorted, it's time to start looking at the wiring. There is quite a bit of wiring to do for this PCB, although you will be doing quite a lot if you're buying this printer anyway, so hopefully you've got the right tools. The wiring for this PCB uses 3 different connectors: JST-XH, Microfit 3, and bootlace ferrules. For me, I use the same crimp tool for the Microfit 3 and JST, and that seemed to work absolutely fine. And then a specific tool for the bootlace ferrules, which obviously crimps in a slightly different way. The method I used for doing the electrical assembly was to finish the build of the whole printer first, get it mounted with the enclosure to the back of the printer, and that way I knew where all the wires needed to go to. So I kind of managed them, I kind of on the head and around, and make sure they're going to go to where I need them to go, route them all down, and that's where I can start getting length. So you can cut the wires to an appropriate length, and then kind of partially remove them from the printer so you've got space to do all the wiring, to put all the JST-XH connectors on the ends, as well as the bootlace ferrules, so you can wire everything into the PCB without loads of excess wiring. Once you've got the printer wired to the PCB, all you then need to worry about is getting the PCB wired into the control board. To do that, I started by cutting all the wires to exactly the same length, so I knew approximately how far the enclosure was going to be from the printer. I then put a microfit terminal on the ends of every single wire, and I could then plug those wires into this PCB, and that was kind of this half sort of done. Of course, pluggable terminals with the bootlace ferrules as well. Once that's done, I can take all those wires towards the enclosure and do that end separately. Cutting wires and reducing lengths if needed, although it's not mandatory. There's quite a lot of available space in the kind of electronics box, so if you have a little bit of excess, it's not the end of the world. All the wiring diagrams are included in the instructions. They look like this. Where I've put colours on these diagrams, it doesn't mean the wire has to be that colour. It's just a reference to the original wiring diagram and general wiring colours that are used, just to hopefully make it a little bit easier to get that visual confirmation that you've done it correctly. Since there's no controller or processing on this board, there's no firmware configuration or anything to do. Once you've done all the wiring, that is literally it. You're ready to go. One thing I've not mentioned so far is the LEDs. They're not really there so you can kind of watch them flash the whole time and the printer's always blinking. It's basically there as a kind of diagnosis tool so you can check that there's power going through the board. It's worth checking that these work fully correctly as you set the printer up for the first time, because otherwise it won't be very useful down the line, because if they weren't working initially, them not working then won't really tell you anything about it. If you do need more help with anything to do with this PCB, the place to go is the Discord channel for Vector 3D. There's a channel specifically for getting help with this PCB, so join in there. Either others or myself will be able to help you if you have any questions or if you need some additional support. Obviously, don't put your order numbers and phone and address and stuff in that chat. That would be a silly thing to do, but post your problem there, and if we need to address something privately, we can do that separate. That's pretty much everything I wanted to tell you about the PCB, how to set it up, and where to go, support, and all that kind of stuff. So now let's go through a bit of Q&A. I've often been asked, if I used a different control board other than the standard stock one, is it compatible? Yeah, it's going to be pretty much compatible with any control board. It's sort of control board independent. There's no special logic or firmware configuration that you need to do for this board. If I don't use Clipper, will it still work? Yes, absolutely fine. There's no firmware configuration or firmware requirements for this board, so any firmware will be just fine. Does it support the BL Touch? It does. So on the control board, there are plugs for servo and probe. If you're using the inductive probe, which comes with the printer as standard, then you just need the probe pins. If you're looking to use the BL Touch, you'll need some of the probe pins as a Z minimum, but for the servo, you will need that fully for the BL Touch, because the BL Touch is 5 pins, 3 of those are servo and 2 other for basically X, min, and stop. So yes, BL Touch, absolutely fine, and inductive probe, but obviously not at the same time. How many kits do I need to purchase? The way it's designed is for single kit, single printer, and that's the way I have it set up. So all the stuff from the printer goes to the PCB, and then the PCB wires are disconnected there all the way to the enclosure. That means the maximum amount of separation is printer and box with a wire. If you want to have box, wire and printer all completely separate, then you would need to buy a second kit. I don't necessarily see much advantage to that personally, but You can put this you can have it run in reverse. As I said, there's no like special logic. So it can work in two directions if you need it to do that in the box and on the printer. That's absolutely fine. The included instructions don't list how to do that. It wasn't really designed to work that way, but as long as you're happy doing the wiring for that, it is capable of working that way. Is it compatible with drag chains? So yes, it is compatible with the squirrel brain, that's very difficult to say, drag chain modifications, although not the standard ones. There's a special modified design specifically for this because it does take up some of that valuable space at the rear of the printer, which the drag chains also utilize. Will you do the assembly for me? So while I'm not really looking to do soldering assembly, I have authorized resellers to be able to do this. So you can get them pre-soldered as an assembled kit if that's what you want. So you can buy it literally just like this with connectors and stuff as well, obviously. But that's not going to be from my shop. You just need to look for resellers that will do that in your region. Can I, or how do I install this on another printer? So there's no logic on this board, so there's no information. It doesn't know what printer it's being installed on. Any components that get plugged in here will be passed through to these plugs at the bottom. It's as simple as that. Same for the power. So as long as you obey the power limitations of this board, which is around 7.5 to 8 amps for these connectors and traces for the heaters, then you should be fine. Does it support 3-pin fans? Yes, as it happens, it does. So 3-pin fans is something that I would like to see more of. So as a result, I decided to implement appropriate design to use 3-pin fans. So that's hopefully everything you need to know about the divider PCB. Links are in the description.